Hello, welcome back to the channel. So let's continue our discussion on separable differential equations and let's solve for the solution of this differential equation over here with this initial condition. So this question is an easy question, but there is an important point that we'll cover in this video regarding the solution to this differential equation over here with this initial condition. So let's first try solving the separable differential equation. So we know that our dy by dx is xy upon x square plus 1. And then based on the knowledge of the prior videos, we know that in order to solve these separable differential equations, we move the similar variables to one side. So we'll have all the variables in terms of x on the right hand side, and also let's move all the variables of y on the left hand side. So if we do that, we'll get dy over y equals x over x square plus 1 dx. And now we can basically integrate both sides. So if you integrate both sides, you see that the integration of 1 by y dy is ln y. And then for this indefinite integral, you can solve this using substitution. So if you'll solve this using substitution, you'll notice that it will be basically 1 by 2 of ln x square plus 1 in this case. And then you'll add the constant of integration as well because you're calculating an indefinite integral. And now in order to get rid of the constant of integration and have a specific solution, we'll use the initial condition. So now let's use the initial condition given. We know that y of 0 is basically 3, which means that when our x is equal to 0, our y value is equal to 3, right? So now if we substitute the values of x and y in this equation, we will get ln absolute value of 3 equals 1 half of ln absolute value of 0 plus 1 plus the constant of integration, right? So now you'll get ln 3 equals 1 by 2 ln 1 plus c, and you know ln 1 is 0, so your c is now equal to ln 3 in this case. So since you got your c, you can use the value of your c to get your final solution, the final function, which would be the solution to your differential equation, right? So now if we substitute the value of c as ln 3 in this case, we will get, so this would be ln y equals 1 by 2 ln x square plus 1 plus ln 3. And now since we want a function at the end, let's represent this expression in terms of y of x, right? So now let's have y on the left hand side and the function in terms of x on the right hand side. So in order to do that, let's simplify this expression over here. We know that this expression can be easily simplified too. So left hand side will be ln absolute value of y, and for this expression we can use the property of logs. So we can shift this constant to the power of this expression. So this would be, the first term on the right hand side would be simply ln mod x square plus 1 to the power 1 by 2, which is basically taking the square root, right? And this would be plus ln 3. And now for this expression, you can notice that you have x square plus 1, which is always positive. So taking the absolute value or not taking the absolute value does not matter. You can have simple brackets as well. So let's add that. And we know that this is basically taking the square root. So we will get ln mod y equals ln root 1 plus x square plus ln 3, right? And now using the product rule of logs, we can write this as ln 3 times 1 plus x square. And after this, we can simply write, if we take the exponent on both sides, we can write absolute value of y equals 3 times 1 plus x square. So in this case, that is an important point, that whenever you're calculating the integral of 1 by y dy, the solution is ln of absolute value of y. It's not ln y, it's always ln of absolute value of y. So you'll carry the absolute value of y until the last step to simplify this expression. And now you know that the meaning of this expression is that your y is either plus 3 times root 1 plus x square, or your y is equal to minus 3 root 1 plus x square. or simply if you want to express it in different terms, you can write this as simply y equals plus minus 3 times square root 1 plus x squared. But now you know that this expression is not a function, because we know from the knowledge of functions that the function is basically you give one input and you get one output, right? But in this case, if we give this expression one input, we will get two outputs, right? So this expression is not a function. So that is why in this case, we'll have to check whether our function solution is this or the solution to the differential equation is this by using the initial value given in the question. So you were given that y of 0 equals 3, right? And now if you substitute y of 0 equals 3, this basically means that if you substitute x equals 0, you should get 3 for your solution to the differential equation, right? If we substitute x equals 0 in this case, we get y equals plus 3. So that's good, right? But in this case, in the second function expression, you'll notice that if you substitute x equals 0, you get minus 3. So this expression is not the solution to the differential equation in this question. So that is why your final answer in this case would be this expression over here. So your final answer to the differential equation, to the solution of the differential equation in this question will be this expression over here. So that was a very important point that you should consider whenever you're dealing with these absolute values, because you know that whenever at last you have such expressions, when you have absolute value equals a function expression, you always take plus minus sign, right? But in the solution to the differential equations, you'll have to check with the initial value, because you'll get only one solution to your differential equation in this case. So it will either be the plus 1 or it will either be the minus 1. So for example, in this case, if your y of 0 was minus 3, then you would have chosen this equation rather than choosing this equation over here. So I hope it makes sense. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.